All right, so let's look at the PowerPoint for how we would solve this. Now, this is just a series circuit. So if you thought, man, is this too easy? Yeah, it kind of is. These series resonants aren't too bad as long as you can use the formulas. So it is just a series circuit. So in order to find I, our favorite law, as always, is Ohm's law. So the first thing that we're going to do is find the Z total. Remember that you have to put the J components on the reactances, positive J for inductors, negative J for capacitors, but you were given the reactances, so all you had to do was put those together. And we see that, yeah, the Z total, this is a series resonant circuit, which was in the description, which is why these are canceling out. We can solve for it, V equals IZ, so put the V over the Z, and we get our current. Now you could use a voltage divider rule to solve for part B, or you could just multiply the current by each of the impedances, right? V equals IZ is true for the whole circuit, which is what we did here, or it's true across each element. Since it's a series circuit, it's the same I going through each of them. So the resistor voltage, the inductor voltage, and the capacitor voltage, and note that these two are opposing each other, right? And so the voltage drop across them cancels out. And then the quality factor, this maybe is the only part that could have tripped you up, is that the X in that formula that says X over R, it can be the XL or the XC. It's the same X because we're in a resonant circuit, right? Where XL equals XC. So that's why the formula sheet just says X. It's not adding two of them up together to make 60. It's just 30 over 2, and that's the ratio, and it is greater than 10, so the rest of the formulas all work out. And now, if we don't have any questions, we'll go back to breakout rooms.
Yes, sir. Like, why did we drop the J's on the VL and the VC?
VL and the VC. We didn't drop them. We went from rectangular format to polar format.
Okay, yes. Gotcha.
And so this angle 90 is J. This angle negative 90 is negative J. All right, all right, so for D through F, if Fs and Fs is the special frequency that is the resonant frequency, is 5,000. What is the bandwidth? Once again, one of those formulas that's right there on the page. You just take the bandwidth, resonant frequency. I wrote it here, Fr. Up here it's Fs. Like we said, they're interchangeable. We can solve for the bandwidth of that curve, that graph that we discussed earlier. And then the cutoffs, as far as what is the effective 0.707 of the max current, the range that would provide that current is right here. And then each of these parts, and this is the only one where you had to rearrange the formula, but we take the regular formula that we've been doing, since right after the 6-week exam, and we have 2 pi f L, and we just rearrange it for the L, the inductance. And so if we know our resonant frequency and we knew the reactance that was being canceled, we get 955. Remember to put in engineering units. So 955 microhenries. Inductance is always in henries, and capacitance is always in farads. Once again, just rearrange that formula, 1 over 2 pi fc, and we can get the capacitance.